In this video, I'm going to show you how to simulate rigorously with FullChip using a HyperLith litho model. Here we have a GDS file. I'm going to run FullChip. I'm going to create a new FC file from the GDS. Loading the GDS. FullChip needs to convert the GDS to an LDB file, which it's doing here. And so here is an LDB file, or this is the GDS loaded. It's been converted to an LDB file and loaded. So you can use the middle mouse button to zoom in and out, and you can use the right drag to pan, right click to zoom all. So first step is to create a litho model. We're going to choose a HyperLith litho model as opposed to a FullChip, which is a fast Hopkins with a thin mask. This is using the full rigorous capabilities of HyperLith. So we load a HyperLith setup file. So here's a HyperLith setup file. And just to show you, I've got HyperLith in this window. This setup file has the full rigorous using trig, has the annular illumination, and it has a resist model, which is the full physics, and it has shrinkage and NTD. It's an NTD resist model. So this is just a HyperLith file. We're not going to talk about how to set that up today. We're just using this. So we've loaded the HyperLith file. That's most of the configuration for the litho model. We're going to just set some numbers here saying that's a 22 nanometer characteristic CD. The tile size we're choosing is 600, which is quite a small tile, and a guard band of 200. Just for the demo today, we'd choose a small tile, but you would go larger. But you can't go too large because this is not a fast model, this is a rigorous model. So we're going to set the background to clear and the foreground to absorber. These are layer names that come from the mask technology in HyperLith. These are just the default layer names for the mask technologies. And it'll accept a thick resist model coming out. We'll put 9, we'll interpolate it to having 9 samples in the Z direction. It is not dark field. Okay, so that's our litho model. Next, we create an op. An op is an operation. In this case, we're going to add a new op, and the op is a verify or simulate op. Okay, now this op is taking layer 0 as the input, and it's going to output the contours to layer 0, 10. Okay, and we're not going to do a PV band with the multiple outputs. The only other thing we need to configure right now is the litho model. And there's only one litho model. We choose that one. That's the one we defined over here. So we defined a litho model and we defined an op. And the op does nothing more than simulate a region. Now, we don't want to simulate this whole area. We could. That would take a long time, especially with a rigorous litho model. So instead, we're going to add a region. We're going to zoom in and just pick a region here. I'll add a region. By default, that region is the size of the view. I'll select it to be the nominal or the current region, and then I'll just center it, or I'll put it here. Now you can load a file or paste in numbers here, but I'm just going to type in numbers. So I want a 400 by 400 region, which is 400 nanometers. And then I'll center it on this corner so we can get some interesting edge effects here. Okay, we've got the litho model defined, we've got the op defined, we've got the region defined. Now we're going to run the op on the current region. You can just right click it up here and say run current region. And now you see in the simulator tab that there's 9 tiles to cover that simulation region with the guard band, and it's running trig. So it's actually it's farming out to HyperLith to actually run the simulation. I'm going to pause the video while that runs, and it should take about a few minutes. As it's simulating, the tiles, the results from the individual tiles are popping in real time, albeit slowly because the simulation is only using one machine, but we could use parallel processing to have it go much faster. Okay, the simulation is finished, and the results of the simulation came back as polygons. And we'll look at the individual layers here. You remember in the litho model, we said that we will accept a thick resist output and put 9 samples. So that means 9 layers, and we'll show these two. So show selected only. And so this is the first layer, that's the lower layer. And we'll plot that and the upper layer. And you can see that the upper layer is actually smaller than the lower layer because of this is an NTD, and there's actually a retrograde sidewall here. So we can actually look at all these layers and we also have I'm using the right click to zoom out to the whole mask. Another right click zooms to the previous view, and a third right click zooms to the region, the current region, this R1 region. We can configure a 3D view. We can take these layers and make a 3D rendering from them. So we have to define the 3D view configuration. And we'll rename this. We'll say this is resist from layer 0/10. And that's the name of the configuration. We'll delete these layers that came in by default. We'll add a resist group starting at layer 0/10, 9 layers, resist thickness of 30, and Z coordinate 5. Okay, and so that's our configuration. And now when we press the 3D view, we should get a 3D view down here of the resist. Okay, this layer was selected, so it came in, and it's also showing altitude topography lines, which we can turn off. We can edit the configuration and not draw the altitude lines, and recreate another 3D view. And we can get the orientation of these 3D views the same. Shift 1 to memorize position 1, and then 1 to recall position 1. So that's how you simulate rigorously and look at the 3D output of the resist.